We are in the first wave of the AI revolution. And I think that it's going to be far bigger than we can ever imagine. Because, as Bill pointed out, we haven't even begun to start using it as a thinking partner. And it's going to challenge our intellect. So this is not going to reduce our intellect. It's going to make us far more intelligent because we have to ask the right questions. But I want to talk to you today about the next wave. And the next wave, I call it causal AI. It's commonly more socially called physical AI, but scientifically, perhaps more accurate to call it causal AI. But before I go into causal AI, let's just look at, try and understand this paradigm we're in. We're in a paradigm. It's a scientific paradigm, it's a social paradigm. And you can think of this paradigm as, on a sociological level, as knowledge AI. Scientifically, it's about correlations. What we do is we need a lot of data to find all the correlations that is in that data. And the more correlations we find, the more patterns we find. And the more patterns we find, the more applications we have. There's endless applications. It is a fantastic revolution in how to put your arms around all of humanity's knowledge. All of humanity's knowledge, all of your company's knowledge, all of whatever knowledge you can grab, this is how you capture that knowledge. And you can use it and describe it and compile it, and you can do almost anything that you want with it. It's retrospective. You need vast amounts of historical data. It's batch computing. That's why each version update costs several $billion. You need new nuclear power stations. But you can also then think of it more sociologically as an observer AI. It is a computer that sits there, and you feed it data. It's looking at the data. It's an observer AI. So we're in a correlation paradigm. And what you're learning is patterns. That's the learning algorithm. That's the great revolution that came from Jeff Hinton's work and many, many others that started this whole journey. This is amazing. It's revolutionary. But it's almost 180 degrees opposite to how the brain works. The brain doesn't work like this. The brain doesn't learn correlations. The brain learns cause and effect. So the brain is more a prospective AI. It's a real-time AI. It's moving and learning on data as it's coming in. It's continuously learning and adapting. It leverages your memories, even if they're not that good, but it is not learning the correlations and the patterns. Cause and effect is a minuscule subset of correlations. And that's why it only needs so much little energy. It's a tiny, 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 tiny subset of correlations. It doesn't have to learn all those correlations. It only has to learn what is really cause and effect. It's mimicking the way the universe was created, which is cause and effect. But most importantly is that the brain is not an observer. The brain is so good that you think that you're observing. You think you're looking at me. You think you're looking at this room. You think that this is what the world looks like. But this is not. The brain is not. There's no pictures coming into your brain. There's little amplitudes, little fragments. Your brain is compiling this world. You are a participant in the world. You're inside the world that you fabricate, and you're only indirectly looking at the world. So the brain is not an observer AI. It's a participant AI. So that means that if you want real intelligence, it has to be born inside the world. It has to become part of the world, part of the cause and effect of everything in the world. Now that sounds quite maybe fantastical, but why is it possible now? It's possible now because we have started. This is the age of digital brains has begun. You may not know it, but it has begun. Why has it begun? Because about 20 years ago, the Swiss government, they decided they want the recipe how to build the brain. They gave me the mandate. They gave me $400 million. I hired about 1,100 scientists over the course of 20 years. And they knew it was going to be controversial. They knew that nobody would believe it. They knew that my scientists would rebel. And so actually the Swiss government, in the infinite wisdom, actually cemented it in the federal budget, the Swiss federal budget, along with bridges and tunnels, so that nobody could take that money away. Best grant ever. Okay. So we did that, and we delivered the recipe last year, at the end of last year. And we launched then the Open Brain Institute, where we put the recipe. It's about 18 million lines of code. It reads all the data about the brain, all the literature about the brain. It compiles it into knowledge graphs, puts them into atlases, and it allows you to make a fax copy of brains. But we wanted to now give that to everybody, so everybody now can go and do it. We put AI on top of it, so you don't even have to know how to build the brain. You can ask the AI to help you build the brain. It has the code. And so we're targeting what we call neuroscience at the speed of thought. Just a little view. So you can go there and you can create your own virtual lab, and you can start building brains. You can build an insect brain, a fly brain, a bird brain. You can also build a human brain, but the computing costs will be quite significant. You have access to all the knowledge of the brain in almost any species. All brain regions, all the neurons, all the synapses, the proteins, the genes, whatever you're looking for. So it's a central place that is harvesting the knowledge of the brain in order to be able to build copies. You can, if you're geeky, you can have your own notebooks. You can share your code. You can instantly ask how to analyze anything about the brain. You can see the plots in real time. You can simulate it. We did all of this in supercomputers, but now we can do it in the cloud. So we work with with Azure and also with Amazon. And people can now do what we did on supercomputers. You can do it in the cloud. So anybody from anywhere in the world can do this. And you can see how a neuron behaves. You can make hypotheses for diseases. You can say, change this. Let's see how this works. And I'll show you a little bit later. Yeah, it's taking too long. But we put an AI assistant on top of this. We call it OB1, W-A-N, because we want every neuroscientist to become a Jedi neuroscientist, because it's now possible to actually have access to all the knowledge of the brain and actually build brains. We started this, we launched it actually in Davos last year, and within 9 months there are about 500 labs, and it's growing significantly. So everybody's going to start building brains. You can open your lab, you invite friends from all over the world, experts in different domains, in physics, in chemistry, in whatever area you want, and collaboratively you can build brains. That's a foundation. We're launching this also as OBI centers around the world, so that people can actually use it to educate for teaching and so on. And that's also begun now in several places. But what I wanted to tell you about is the AI. So 6 years before this, we anticipated, because we were working on it. People weren't believing, but we were working on it. We knew that the age of digital brains would start. So we started a company called INAIT. Stands for Innate Neural Artificial Intelligence Technologies, because 99% of your intelligence is innate. It comes from millions of years of evolution. It doesn't come from learning. Learning is just a cherry on the top. So it's innate. You have innate intelligence. The machine knows how to learn cause and effect. That's what it's designed for. The brain has been designed to embody itself in this world, by learning the cause and effect of every single thing that you experience in your life. So we built the full stack. The first thing is we had to crack the neural code, how to interpret the language of the brain. And we have a brain operating system now that allows us to program the brain in any domain of expertise. And we solved the causal learning algorithm, which is the analog of backpropagation, transformer learning, and so on, but for the brain. And so we have two platforms. One is the digital brain operating system, and the other one is what we call the I am platform. It's I am because I become. The AI becomes. I'll give you a few examples. Here is a few neurons learning cause and effect in real time. It's never seen the double pendulum. It can balance the double pendulum better than a circus act. But it does it within 5 to 20 attempts. Never seen the data before. In fact, when it finished solving it, it just was a stick. It was totally steady. So Camilla said, but that's a boring demo. So we added chaotic wind to it. So this is with chaotic wind. Now, just to give you a comparison, about 6 months ago, Google DeepMind launched their benchmark. That's the world's championship in the double pendulum task. They launched and it takes tens of thousands, if not millions of back examples normally to do this with the correlation paradigm. In the causal paradigm, this happens within 10 or 20 trials. With chaotic wind, which means that it's novel situations, it's not possible. It's very difficult with deep reinforcement learning or any other causal type of models. This is also a benchmark. This is also what Google published. But I'll just show you. So this is about 500 neurons. They're learning cause and effect. And you can tell them to be different characters. So here you can say, I want you to be a winner, which means you have to exploit the weaknesses of the opponent. And then you switch and say, now I want you to play nice. And then it has to consider the weaknesses of the opponent. So it's a very nice little mini cognitive task. But what is really remarkable is the speed at which it learns. So it already tries to move towards the ball in the very first game. By game 2, it learns how to hit the ball. By game 4, it learns how to score. And by game 10, 11, it learns how to win outright. Now, as a benchmark again, DeepMind launched Dreamweaver, which also was published, and they needed several hundred examples of how to win, but they call it Dreamweaver because they're generating surrogate data for every example, hundreds of data. So they need actually thousands, tens of thousands of examples of the past, of the history, of patterns, before they can learn this task. And this can be done with causal learning in a fraction of time. And it continues to learn forever. You never have to take it back for a version update. Continues to learn forever. So you're not talking 10%, you're talking 100 to 1,000 times more efficient learning in real-world situations. If you give it data, so this is data on stock prices, on hobbies, on energy, power usage. This is within the timestamps, and it's never seen the data before. Doesn't need any historical data. In the beginning, it's trying to sync up with the data, and it locks in to the data. It becomes the data. So we call it I am data, because it becomes the data. It's learning dynamics, it's not learning patterns. This is the next revolution. Because once you've learned the dynamics, you are the data, so you can generate the future. So with this, we're building 3 ranges of products. The first is called Future Complete, And actually, we're calling it the complete range of products because it's kind of completing the AI revolution, because you have the AI on the past, which is the correlation paradigm, and now you'll have the AI on real time. So the first is called Future Complete, which can extend your sales into the future, your revenue into the future, your supply chains into the future. It becomes your supply chain. It becomes whatever it is you want, and it can actually identify where it's going to go. And that's already being deployed right now to several companies. And then there's Cognition Complete, which is causal reasoning for continuous dynamic decision making. It's like a data scientist's dream, right? You just in real time, can ask causal decisions. What should I do now? And then there's Behavior Complete, which is the ultimate robotics. That's real-time robotics. Imagine if you wanted to send a troop of robots to the moon today, independently to set up a base. You think that they could do it? There's no data. You can maybe simulate some of it, but there's no data. If you want to send them to mine an asteroid, I'm just giving extreme examples to see what the gap is that we have in robotics. You want to send a troop of robots to go mine asteroids. There's no historical data. They have to land there, and they have to learn on the spot. And they have to understand all the dynamics of their surroundings, and then they have to exploit that asteroid and learn how to mine it. That can only happen in a causal AI paradigm. Cannot happen with correlation paradigm. You will have to generate surrogate data until you have more nuclear power stations to cover the entire planet. So this is the range for AI. These are just some examples, and in the interest, I will skip it. So we've built the full stack for the causal AI paradigm, where you can now harvest $100 billion of research on neuroscience continuously through the Open Brain Institute. It's open. All the code is open. All the data is open. The software is open. Everybody can be participating in all of this, understanding the brain, building the brain, exploiting the brain. And then we have an AI platform that turns it, that teaches it, shows it how, switches, actually activates the ability, its natural, inherent ability to learn cause and effect. It activates it on a domain like, let's say, I mean, I'm just choosing supply chain because someone mentioned it's boring, but it's very valuable. But you could activate and say, okay, this is your domain. So it's also very safe AI. It's also the only AI that can give you explainable AI, because you understand the cause and effect. You can chase the chain of causality. So these are being deployed. They're tiny. They consume no power. 500 neurons is nothing. You can put it on a tiny little edge inside your fridge, and it'll be a brain that learns the way the brain learns. And it can go from cloud down to the edge. We partnered with Microsoft, and we've begun distributing this, and we're doing proof of value tests with various companies. And it will be discussed more at the Open Science House. Thank you.